So that's the plan. It's gonna be fun. We're gonna be doing some cool stuff. Hopefully, it's a good time. So I went ahead and did some reading about all this beforehand to make sure I'm not like stumbling the whole time. This is a great wiki to go off of too if you're interested in learning more about it. But I think we should be able to make it pretty far without running any problems. So, oh man, I have a good name for this too. You ready for this? It's a Chip 8 emulator, right? So we call it Chipmunk. Right? Pretty good. I thought of it like 5 minutes ago. That's not how you do this. You do this, and then you do cargo, new bin, Chipmunk. Chipmunk. All right. I'm gonna back this up to Git. Let's go. I want to sign in my Git on stream. Oh, we'll figure out. I'll post the Git link after. Oh, what's up, Scammo? How's it going, dude? Hope your day's going well. Thanks for the follow. Appreciate it. I don't know if you caught what's happening here, but we're building a Chip 8 emulator so we can play old school games, but we're writing it in Rust because Rust is cool and writing from scratch. It's gonna be sick. So we're calling it Chipmunk. So, oh, you read my Rust article? You find it useful? Sometimes I feel like my writing sucks, but I feel like everyone thinks their writing sucks. Dude, Rust is a lot of fun. I come from web dev. That's what I do it as a job mostly. I mean, I do some backend stuff, but that's definitely what I'm most proficient at. I find like most backend languages and frameworks like pretty boring, but I definitely like fell in love with Rust pretty hard. I've been using it for like over a year. It's like the only thing I like writing side projects in. Oh yeah, so Rust has like a huge learning curve. Even I would say I'm like not even like amazing at Rust. There's a lot of stuff about Rust I don't understand, but it's one of those things you really have to just write, and you kind of figure it out. Learning Rust for Solana though sounds kind of insane, just because it's like such a niche application of Rust. I feel like in terms of how you interact with the Rust in that context versus the average context. So you can build anything with Rust. That's the best part. You can build web services. There's even WASM based front ends that you write it in Rust and then it compiles to WASM and then you can load it in the browser. It's pretty neat. It's called U, I think. I tried it a while ago, but it was kind of underdeveloped. But I'm excited to see where that goes. All right, I'm gonna start. Hopefully, if you have anyone has any questions about Rust, even though I'm not an expert, I think I'm decent enough to get started. And hopefully this makes sense. So, first thing we got to do right away just start writing some general stuff, and then I want to write like the right data structures and something to store all the registers and the memory and everything like that. And we'll sort of knock them out as we go. Cool. So we're gonna load this up. I had some Vim stuff that was broken in last stream, but I've fixed those. So if there's any other problems, hopefully there's not many other problems, but all right. Save as main. We're gonna need. What are we gonna need? We're gonna do this. So we can kind of just have it. I wonder how bad it would be to have a. We need at least an emulator, right? Emulator. This needs to be included in the tree mod emulator. Okay. So yeah, we have this emulator. We need a pub struct emulator. And then what we're gonna need, so there's 4 kilobytes of memory. So memory. It's a slice of that lives for the entire program of U8s. U8. This tick static is probably confusing for people who are not familiar with Rust. I actually went over this last stream too. Tick static just means this block of memory, this reference, this slice, basically, this slice of U8s, this reference is valid for the entirety. It's not actually the entirety of the program, but like it basically owns it. Like it doesn't have to worry about the borrow checker. If that makes sense. So static things don't necessarily have to be in the static part of the binary. You could also just leak something, and then have a tick static lifetime. But we basically need 4 kilobytes of memory. This is gonna be 4 KB of memory that lives for the entire program, the entire emulator, entire program. Okay, full emulator. We have a new here, which turns itself. Probably to do load ROM eventually. That because the ROM gets loaded into a certain offset of the this giant block of memory. But we're gonna turn self with the memory. So what we're gonna do here, we're gonna make a 4 kilobyte slice, okay, and then we're gonna purposefully leak it. We're gonna purposefully leak it, so that way it doesn't get dropped by anything, and because we want to live the entire program. There's never a time we want to get rid of that because there's only going to be one emulator. The emulator is the entire program. So, let bytes like mem is a vec new with a capacity of 0. Actually, how do you make a? Oh wait, no, we don't need that. We can just do 0 what mem size. Which is this is a U size is a 4096. What am I? Wait, I'm having a brain fart here. Rust create slice stood slice Rust create 4K block of memory. I can leak a vec. But how do I create a slice? What am I having? Create fill vec fill all, like create vec with n items. Yeah, 0 for, okay, here you go. 0 is for a specific size. Oh, you do vec like this, and then you can dot leak. Okay. Yeah. So we create a memory of 4096 zeros. And then we leak it onto the heap, and then we're referencing it in this emulator. To get rid of these errors, I'm gonna do let mute emulator or m equals emulator. Let's get rid of some stuff here. Yeah. So something to keep in mind here. I'm gonna add it on here. 0x00 to I wrote this before this. I started the stream, which is why I'm just saying off the top of my head. This is historically where the chip 8 interpreter lived. We actually don't need to do that because our interpreter isn't inside the running, like, we're not on an embedded system. It's living outside that, right? 0x0 20 x 0a0. Let me double check this here on this. What are the, there's a, most parameters written for do not access memory below location 0x20. Yeah, you don't need it, which makes sense. I remember it's in here. This is where I actually found. I was reading this article earlier. That's what made me so excited to build this. Yeah, so then 0x50 to 0x0a0 is for the pix, which is for the pixel font. This I'll talk about later. It's pretty ingenious though. And then OX200 to OXFFF is the ROM and everything else. Okay. I remember looking through that and didn't find anything more related. You talking about this build for build your own X? There's a lot of stuff. Yeah, there's a ton of web stuff here. You can build your own React front end. It's like a building a custom React renderer, writing Redux. You build your own. I did which one was it? Build your own React. I think it was this one. Yeah. This one has this cool. I remember this one having this cool like animation stuff. But it's a little bit of I didn't mean to go off topic there, but this is cool. If you're into web dev and you want to know how to build your own React, this is also a fantastic article. Okay. So we have the memory. We also have 15 general purpose registers. So let me look real quick. What are these registers? How many bits do they hold? They're 8-bit registers. Okay. So they're just U8s. I want to have a nice data structure for this. I don't know if I need to. We're just gonna do another tick static of U8. And this is I'm gonna lay this out a little differently. Actually, no, I can just do it like that. I could have like a registers abstraction that like hides this for me, or I can put it in emulator. Here's what we're gonna do registers. Struct red pub struct registers. I add this to the main. Pub struct registers. This is gonna have inner. Which is gonna be another tick static of U8s. This has 7. So it goes V0 to VE, V0 to VF, but VF is special, so it's actually 16. So doing all these like bitwise and remembering all the indexes are gonna suck. So what we're gonna do 16 registers, V0 to VF, but don't, okay? And then impl registers, pubfn new, return self. We're gonna do the same thing here we did in the emulator, which we're gonna generate this memory of const reg count is u, which is a u size, and it's 16. 16, we're gonna leak it. Registers. We're gonna return self with the regist. We just do inner. Now we can just do registers. I'm just gonna own it. So memory, let registers equals registers new. Okay. Zoom out a little bit here. Okay, so we have the registers now. So let's just go through and actually have a way to access these. I want to figure out what's the API one here. So what I could do is, so I need to have a get and a set. What seems like it would be nice is if I could do like registers. Let's say I'm in here, registers.like.v0, right? I can do v0 mute, which then gives me a mutable reference inside the registers, and then I can set whatever I want. But do I really want to be handing out mutable references? I don't know. It's kind of gross. So you do like get v0. I can do a v0. You then, if you want to get it, but then you could do registers.set v0 with like a u8. I don't know. I'm on the fence here. I think I'm going to do. I could have public accessors on these. What if instead of having these behind methods, I just had like v0, u8, v1, u8. And these are both like pub. Then you can do registers.v0. And you can do like equal to 1. Yeah, I think I'm just gonna do that. This is like kind of verbose, but you know, I think it's actually cleaner. Because then otherwise I'd have like 2 methods each. 7, v8, v9, v10, v11. Wait, no, it's hex. It's not v9. What am I talking about? V. Then you go A. Thanks for the follow, dude. Mateo. I butchered it probably, but thanks for the follow. I appreciate it. VA, VB, VC, VD, VE, VF. So this is a special one because if you look at our used as carry flag, but also used as, so default used as carry flag, okay? Subtraction mode, it's used, it's the no borrow flag. In drawing mode, it's used for collision detection, which I know sounds crazy. But the reason why it's used for collision detection is because when you drop the pixels, it does an XOR. And so when things flip from on, what was it? It just talks about it here. Graphics. The carry flag is set to 1 if any screen pixels are flipped from set to unset when a sprite is drawn to 0. Is drawn and set to 0 otherwise. This is used for collision detection. Pretty cool. I don't know if, I'm still contemplating if this is the right way to do it, but it removes a lot of like getters and setters. And a lot of, like, I feel like I'll just make an error. So now we gotta set them all to 0. Which luckily I can use this. But it might be better to do like this. Bang. Oh. What the hell? It was close. Let's try it again. Whoop. Bop. And paste. I don't know what this like. Okay. Okay. Yeah, it's complaining, but it's fine. We can just remove these. Missing VF. Unclosed delimiter. There we go. That was faster than typing it by hand, I think. Now we don't need this leak. And we don't need this. I can close this. Okay. Nice. This way, what's good about this is that if we need to add like some nice helper methods to wrap common stuff we do to the registers, we can just do that. We can honestly use write our ops in here, our op codes. We can probably handle them in here, but we'll figure it out as we go. Okay. Back to emulator. So we have the memory, we have the registers. Oh, okay. Then we also have the as it's jumping between opcodes, you can have 12 layers of stack. So you can like jump into functions 12 times. And so there's also a program counter. Create your own. Build your own X, not C. Yeah, this thing. I'll make sure, I was looking at this. I'll make sure I'm on the right track. But, well, I know I'm on the right track, but I just want to make sure I got that 12 thing right. Ooh, yeah, okay. There's 16 registers, there's 4K memory, it's 16. I thought it was 12. Stack. The original version had 12 layers of nesting. Modern implementations usually have more. Okay, you know what? We'll make it 16. The emulator has the registers. It has the program counter, which is a U16. Although, is that technically a register? It's hard to say. I might move it to registers just to keep it nice and registers. PC pub piece. Do I? This is a U16. Uh, it's actually using 0 because, as we remember, we talked about in the memory emulator. The memory starts at the ROM starts at 0x200. So we actually can just do it as 0 200. 0x200. And then we don't need to. So now we need to keep track of the stacks. Stacks. This is going to be an array of U16s. U16 size 12. Const stack size equals stack count. Sure. Make it 12. This needs a U size. Then the stacks is a. You know, this can be a vec. This is because we just want to get the top all the time. It can grow. We just make a vec. A vec of U8s. U16s actually because of the program counter. Program counters. Because when we hit a return instruction, we need to pop off where we were on the stack and change our program counter to there. So our stack is an empty vec. Vec. We can just do it with capacity of stack count. This is like a micro optimization, but since we already know how many stacks we're going to put in there, we can just prevent any resizing with just using that. So here are stacks. There are registers. There's also an index register. We should add that. Let's go to registers. Oops. Registers. Program counter. Then index. It's like the I register. This is actually 12 bits. Why it's 12 is kind of weird, I think. The address register, which is named I, is 12 bits wide. So we get U16. 12 bits wide. Doesn't like that it's not snake case. Can we ignore it? We could call it index, but I is better, I think. These could definitely be called lowercase I. Index register I is 0. Boop. All right, cool, dude. So we have that all set up. Let me think of what we want to do next. We have like most of it set up. So we could start going through the opcodes. I think this is better if we pick a nice example that we can work off of. So I basically want to have like a hello world ROM. Chip 8. Hello world. Nice. The hell is this? Wait, what? Oh, these are the instructions. 6278. What's that instruction? 627. So 62. So 6x being x being v2 equals nn. Cool. So okay. Our emulator's gonna be handling these opcodes. Is it? I'm trying to think. Is it worth it to write enums around these opcodes? Before we do that, though, let's make a folder called romps. That's not a folder. That's a file. Oops. ROMs. Okay. Let's add this rom slash hello world dot I guess rom. Can I want this in like binary. Just, I know these are the instructions, blah blah blah, whatever, but hello world dot rom. There we go. 20 bytes. To have the raw copy link. Got a wget and then this and dot slash roms. Nice. Cool. Thick, dude. All right, I want to back this up on to GitHub already because I'm worried I'm gonna delete a file on accident and then just totally screw everything up. So let me create a new repo real quick. Chipmunk, a chip8 interpreter, virtual interpreter written in Rust, public. This is gonna be all MIT license, but I don't want to have it initialize the repo. Okay. Add the readme.md. Chipmunk. A chip8. I should add the link. Written in Rust, baby. Oh, this was a project I built during one of my programming streams. You can find here. Twitch.tv. Yeah. Code / chipmunk. Yes. Git add. I don't like including the git lock or cargo lock. Just because it annoys me. And commit. Push origin master. What? Oh, I'm actually so stupid. Duh. Git remote add origin. Git push origin master. Whew, man. Sure though. In case anyone, we need to drop us in the chat. I need another window open here. There you go. All right. Now we're backed up. That's good. Now I'm feeling more comfortable. I don't want to like delete something and be off. That would suck. Okay. So we have the memory, we have the registers, we have stack. We have this, all that stuff. Now we need to load the ROM because we want to be able to print hello world. Okay. So here's the plan. We're gonna load the ROM, start reading the instructions, and what we get. I don't really want to have to. Actually, let's just do this. So we're gonna pass in for now in the emulator. We'll just take a bytes at the ROM, which is just like a text of U8. Be tick on that one. Yeah. So we're passing in a reference to some, basically just like a slice. Yeah, I need to have a git ignore on that for my stuff. I could have sworn it usually listens to my git ignore. It's a new computer I built. I built this pretty recently, so I don't have all that stuff figured out yet. But get ROM stuff. Get ROM data. Okay. I forgot how to open up a path. Read the bytes as to open a file in binary mode in Rust. Let me check. How to read raw bytes of file or Rust. See what you got. Oh, what are these ads? You open it, you make a reader, and then you read the end and the buffer. Okay, cool. You can do that. That's easy enough. Who's this? Nano Z Byte. Thanks for the follow. Appreciate it. Glad you're having a good time. Appreciate the love. I'm out here trying. Experiment with streaming. I'm having a fun time so far, so I'm glad you guys are enjoying it. CF code. Not Roth. Chipmunk. ROMs. Hello world. Oops. This needs to return an IO result. And it's also need to include the file, a buff reader. To end, I have to import that. Buffer.to. I actually don't need to pass U8s. I can probably just pass in a vec emulator. Let me just do that for now. like load memory, like load ROM, which takes the ROM, which is a vec of U8, and then this can't fail for this doesn't actually need a ROM. I feel like it should actually. Let self is this, let emulator dot load ROM, and then return emulator. So it returns a self, which is a we need a mutable reference to self here. Okay. It matters here. Turns in okay. Nothing. Okay, cool. Later. For byte in. Oh, we need the memory. Well, you just go from the program counter, I think. The program counter is a register, but I think we might need it here. So we're at OX200. That's where we start. Yeah, okay. Yeah. Okay. ROMs get loaded past starting at memory location OX200. So for byte and ROM dot, we want to do into iter here because we don't want references to the bytes. We want the actual bytes. Let m let idx mute idx, which this is going to be a U16. Yeah, this is OX200. So then self.memory at idx, the value at that, we're going to dereference it, and then it's set to byte. Because the oh, you wait. The type and U8 cannot be indexed by U8. Oh, this needs to be U size. Oops. Type U8 cannot be dereferenced. Is behind a and. Okay, I need to do get mute. And then I need to dereference. Expect memory shouldn't have been memory. Try to load. Let's do a format here. Try to this. So there's no way we go over 4K. Like for any of our examples here. So we're just going to expect try to load in ROM past 4K region bytes. This is set to byte. Cannot borrow self.memory. Expected mu8 found left hand side. Okay. Cannot borrow self mutably. What does it want? Expected immutable reference to U8 found just a U8. Doesn't this get a U8? Okay, .get mute .unwrap equals byte. Borrow self.memory as mutable. Now you have a static mutable? Ooh, that's what we needed. IDX plus C equals 1. So we need a static. It needs to live for the entirety of the program, and it needs to be mutable. Got it. That was a weird error message, though. So we can go back to expect. Load. Try to load. ROM went over 4K. So now we're loading in the stuff. We do print. I want to load. I just want to get like the first 50 bytes of this self.memory. I do like 0 to 48. Emulator. The size for U8 cannot be known as compile time. I know, I know. Yeah, okay. Let me do that. Try to run. It's all set to 0. We're not. Oh, we're loading the ROM. Am I even passing the ROM? Kernel in. Let's print the buffer. Buffer has stuff, but it doesn't have it in here. Oh, wait, because it's not. I'm stupid. It's not at 0 to 48. It's at mem size. It's not 0 to 48. It's mem size. No, it's not. It's the OX200. OX. There we go. It's offset by 200 because we're starting at 200. Yeah, look at that, dude. The bytes are loaded. Sick. Now we have bytes loaded. That's pretty cool. Now, we're going to go now. So each of these bytes represents an instruction, as you can see on this thing. So, we got to figure that out. So, chip 8 has 35 total opcodes. Okay? 35. It's actually not too many for like an emulator. Modern architectures have a way more. So 35 is pretty decent. So these are in decimals because they're U16s. We need to match these opcodes. So we could parse them as opcodes. We have like a nice opcode struct. We could do that. That might be better. What we could do, ooh, here we go. Instead of loading the ROM into the memory, we could like parse them as like a vector of opcodes and then just emulate over that. But I actually think this is better to just go across, to just, okay. Yeah, okay. Sorry. I was just having a brain blast here. I just want to make sure I'm having it all right. So we have our emulator. Now we need a way. We don't need this anymore. Okay. We have way to load ROMs. Now we need our like start, pubfn start, which does nothing. Doesn't return anything. So here's our loop. Emulate cycle. Okay. Then we have maybe draw. This is to do because we're not doing that yet. We probably won't. We won't do that. We won't do that this stream. Also set keys. This is also to do. This will not be done this stream. So we're always gonna do emulate cycle. Okay. Have a pub or just a normal fn cycle. Okay. So what happens when we're in a cycle? We fetch the opcode. Fetch opcode. Okay. We decode opcode. We execute the opcode. And then we update our timers. There's two timers in chip 8. There's a delay timer, which is for delaying stuff in the games. And then there's a sound timer, which when it's non-zero, it makes a beep. We'll do that later. So that stuff is not supported yet. Okay. So we're just gonna we'll figure that out. That's later. This is to do. Okay. So let's do a fetch opcode. Now, what does that do? We just fetch it at the program counter. So the program counter is 2 bytes wide. So we bump it. We read it, then we bump it. So the opcode is going to return us. So this is where I'm trying to think. We could return like some sort of opcode thing. Opcode, and opcodes could be nice. Like it could be like a giant enum. I think that's what we should do. Oh wait. Oh, I have an idea here. This is gonna be nice. Okay. Opcode.rs. Oops. Pub enum opcode. We go to main. We gotta include it. Mod opcode. Okay. We're gonna do derive debug here. What's our first opcode? Go back to that this hello world .md. 6278. 6278. 62. What is that? That's a set x to vn. This is a. This is a set instruction, right? Let's do a set. I don't know if that's actually true. Like a set vx instruction. This has the. Wait a minute. So here is the thing. If we have set vx, we store which vx it is. It's hard for us to get a. I'm trying to figure out a way to like abstract this nicely. I think we just leave it as the register number. registers is just a U8. Have the value? Is that what it was? NN, what is NN? NN is an 8-bit constant. Oh yeah, okay. The value, which is an 8-bit constant. So this is where we can get pretty fancy. This is one thing I love about Rust, okay? We can impl try into opcode for a U8 array. FN try into, okay? We can match self if we hit, what is it, 6 anything. The UA actually. This is nice for some things, but since we actually need we need, it's 6x. Ooh, because it's like half a. If only there was U4s. That'd be nice. Yeah, there's no U4s. This isn't as nice. I can't use this fancy thing. Yeah. Trying to think. Okay, it's whatever. Doesn't matter. But we can still, we can actually still do this. It's just nowhere near. It's not as like super nice. We know that there's at least 2 bytes. So let, right? Aren't they all at least 2 bytes, right? Yeah. So like we need byte 0. Think actually. Doing a little thinking on the spot. Let's see if I can. I'm trying to figure out like what's a nice way to do this. It doesn't have to be that nice, but I want to do something that's like gonna pay us down. It's gonna have a nice foundation for the future. What do you guys think? Anyone have any ideas here? Any rustations? I might do it ugly now, and we'll refactor later. It'd be okay. We get the first I kind of so I want to. What I'm gonna need to be able to do here is split these up into 2 bytes into 4 parts. I basically need U4s, but I can basically I can split 2 U8s into 4 U8s by just shifting things. I can just get the bottom half every time. That makes sense. I don't know if that makes sense to anyone. Like, all right, let's say I have, what's this? 6n, 6x and n, right? 6n and n. Well, what was it in the? It was what in this README? 6278, right? 6278. I could have OX06, OX02, OX07, OX08. That's kind of what I want because then I can do nice Rust pattern matching stuff on it. So I think that's the way to go. So I need a way to split FN basic. What am I kind of doing? I'm kind of partitioning? Not really. Like stretching. Stretch bytes. Turn 2 U8s, U16 into 4 U8s by stretching them. I don't know if that's really a thing, but it is now. Example. So this is basically what we're trying to do. Stretching sounds cool. I don't know if it's a thing. Stretch bytes. Basically stretch U16. Stretch U16. It's just because U16 every time. We're going to stretch a U16. The num U16 or the input. Then can this fail? I don't think it can fail. Of U8 of size 4. Let res is okay, so I can do that. Not all minute. Let's just do it. Okay. Filler. There's no op. Okay. Opcode, no op. Type is op. Emulator. This is like a emulator. Oh, I can't do that. Struct pub enum emulator error. Unknown opcode. So yeah, stretch these bytes. One sec, I got some milk duds. Those are great. All right. Let's stretch some bytes, dude. So we gotta get the first 4 bytes, and then we gotta shift them. Ooh, we got some like gross bit stuff. Let first. It's U16. Oh, jeez. Get first 4 bits. Get first 4 bits of byte. Rust. Sorted. OX0. Yeah. And then you shift it to the 4. Okay. Yeah. Let first is the input with 0x 0FF. Yeah, let's go a little JavaScript action here. If I have like let x is ox, you do ox1. Yeah, you can. Let's grab that. X. Okay. X and 0 x 0 fff. New string radix 16. Ooh, 278. Dude, I'm not gonna lie. Once you start doing bitwise ops, man, start to lose me. Yep, so we're bitwising. It's late, man. It's late. I'm getting a little slow. Well, I need the. So those are anded, so they're all set to 1. Don't I want? Yeah, wait. Rust. JS get first. Like Rust get first 4 bits. Get first 4 bits of a byte. Yeah. Wait. The lower. Oh, you. That's the lower. So stupid. So yeah, 8, the last one. Yeah. So last is this plus. Okay. So sick. Last. Uh, second. X and 0 x 0. You can't just shift 0 0 f 0 to string of 16. It's 7, but then you need to shift it by 4. Right? 7. Nice. Right? We're on track. Yeah, see, that's the pattern I was thinking of. That second. This is the 4th. This is the 3rd. Let second is the input, and OX0F00 shifted 8. First is the input, and OXF00 shifted 4 or 16. And first, second, third, fourth. But these are you. Yeah, because you're 2, 8 from Big Indian. Sure, I don't care. From Byte. I don't think this matters. I forget like what the ending is here. BE bytes. Where's you from? I hate bitwise. U8, U16 to U8 Rust. I just want the half. Integer shifted to 8 as U8. Go. This is what I want. Stupid. U8, bro. Oh my god. Because it's the order of ops. What's nice about Rust is I'll be able to write tests on this because I really need to test this. This is like so not fun, but whatever. See, it like has to get done. Mod tests. FN test simple. Simple test. Um, asserts. Eek. Stretch. Let expect. See, actual is going to be stretch 16 of what? 0x6278. We're going to assert that this equals 0x06, 0x02, 0x07, 0x08. Can compare. I do as U8. Can compare U8 with U8. Okay. There you go. Error's gone. Let's see if it works. Attempt to shift this ref. What do you mean? Oh. Wait, you're right. Back to the thing. I forgot. Um, this is off the screen for a second, but it'll be back. I just want to see if I can get. I just need to test real quick. So the second works. If we do x and 0xf00, this is I'm testing the second one. I do get 2. Oh, it's not 16. It's 12. There you go. It's testing now. Aho, baby. Bitwise Lord over here, dude. Hell yeah. Listen. All right, you guys might be making fun of me. All right. I know. I suck at Bitwise, but so does everyone. I haven't done Bitwise in forever. That was straight off the top of my head. Cut me some slack. Hell yeah. Okay, now we got these. Now we got a stretch. Now we can do this cool try and op code. So we do let. Oop. Let bytes. We can do let parts is stretch U16 self. Okay. Now here's the cool Rust thing. We can match on the parts. Match parts. Oh, you guys see this? You guys see this? So now we're doing 6xnn. We can do 6 OX06 OXO anything, anything. Oh, buddy. Okay, and then we do this is to do unknown op. We know we turn an error. Turn error unknown emulator error unknown opcode. Okay. So now we have 6. Vx equals nn. We can grab whatever x is. X and wait, can I be fancy and do n? Oh no, it needs n1 and 2. Let address is n1 shifted to the left by 8 plus with an or of n2. Is that what I think it is? JavaScript. N1 is, let's say it's OXF or OXA. Let N2 is OXB. What did I do? I did N1 shifted to the left 8, and then I OR with N2, and then I do this as toString, the radix of 16. Oh, wait, whoa. Oh, A0B. Wait, that's right. A0 XA0B. Oh, we really shift. Maybe you just shift by 4. When you add them, you gotta shift by 4 because they're not actually U8s. They're like U4s. But really U4s since the first half is always 0. This is like kind of funky, but it's all gonna be abstracted away. So no one will know of all the sins that I have committed. Okay, so maybe the address is that. Let register is X. Oh man. Okay, then we do okay, return, okay, opcode, set VX, register, value. Register. Wait, I thought it was an address. Oh, it's a value. Oops. Value. All arms diverge. Yeah, I get it. Dude, that's nice. You see, all right, I had a vision. It was a little ugly to get there, but we got there. We got there in the end. We're gonna abstract this all away, right? So the thing that's kind of annoying here, we're passing a U8 as a register, but it makes me want to go back to our registers function and then get rid of all this. Makes me want to do like a yeah, I don't like this. You could even have like a register enum. Maybe that's what we do. Because then we get a little we can match against that. Pub enum reg bo. this so that maybe let me try with like a few and see how this would look. So we could have a inner, which this would just be a tick static of U8s. What do you need? It can be a U. Let's const reg 16 U8 16. Yeah, I'm gonna add this though. I'm gonna leave this here just because for as a note to myself. And we're gonna go back to emulator because we already did this before, where we leak a bunch of memory in the stack. The memory here actually doesn't have to be a static mute. Wait, can't this just be a U8 mem size? Nice. Ooh. This seems to be a vec 0 mem size. Yeah. Maybe it needs type hints. Let memory is a U8 of mem size is vec 0 mem. We just looked this up earlier. Yeah. Not a vec. Uh, Rust instantiate create just fixed length arrays. Oh, let's see. Yeah, so if you like U8, you can do 0. Ah, okay. Okay, yeah, so you can do this. That's what I thought. Okay, so that's cool. Now we don't have the static. Then we don't have all that. We're not like leaking anything anymore, which is not a bad way to do it, but we don't need to. Inner. Let inner is a 0 of reg count. U size is 16. Okay. So here's the theory with registers. You can do hubfn get. You pass in the reg, and you get a U8. Match on reg. You could even do like a impl, like a try into, or like into U size for reg. Oh wait, this is nice. You basically get, because then your abstraction is basically 0 cost, right? And you do a fn into, you match the self, v self v0, you return 0. Else, do you see how this works? This is so nice. Because then we can enum the registers. We get like the nice fancy. We get the nice names on them. But index or like I you do reg.into, and then this is usize. So then this knows how to convert them. It knows how to convert, using into. This is what makes Rust so nice to use. I don't have to write a method called turn reg into usize or reg as usize. I just import the into for this data structure, my reg enum. I write this function once. Anytime I want to usize, I just do .into. If I have another function for turning into a string or turning into a U8 or turning into something else, I just do .into, and Rust just knows which into input to call. So that's why Rust doesn't have any function overloading, because you instead take something that can turn into the type you're trying to do and you call turn into. It's pretty damn sleek. Okay, so now we have a usize. Then we do. We also need a mutable reference to self. Mutable reference to self. Self dot inner of I. We need a dot get mute I. Dereference it. This can be a get mute unchecked, because there's no way we get a reg that doesn't fit. That's unsafe. Ugh. Okay. Get mute dot expect reg doesn't exist. Okay. This just got get. Oh, see? So we have the get, we have the set. Dot get mute value, which is a U6, U8 equals value. Ooh, that's a nice API. Okay, so then we have a get set. We have this enum. We can turn to a usize. They're basically just indices into this, but it has indices into this inner, but it's a little nicer. Okay, cool. We'll add that later. Right, so since we now have a way to turn usizes into regs, as we can see in our opcode, we're gonna have U8s that are representing a register number. We're gonna want to turn those registers. We're gonna want to turn those into regs. So we can do into reg for U16, no U8. Oh, it's so nice. Then into. So it's a little verbose, but like 0 goes to V0. 1 goes to V1. Oops. 2 goes to V2. And then for now, we'll panic. Unknown registered number. Unknown registered this. V blank. It was a hex. I never tried this. Huh. I guess it works. I'm assuming %x or dash or : x means hex. And then one recently lets me do B2 for binary. That's my guess. So now in the opcode, the register isn't U8, it's a reg. And then we can do dot into, but which it does work, but then we need to go to, this needs to have a debug. See that? Oh man. Okay. So now we can be at the number, and then we turn the number into this enum that we actually care about. And then whenever we call set and get to our registers, it will then know how to convert it to then set the actual memory how we want. So, but now we have a way, our API is way more ergonomic. This is sick. So first opcode should be done. That 6 whatever, the set A500. I want, actually, is there a way to test that? Let's see. In the emulator, we have a start, which is gonna, for now, we're not looping. We're just gonna do it once. Self.cycle. This takes immutable reference to self. Mute self. Then this does self.fetch opcode. This takes, yeah, mutable self. So let opcode is this. We read the PC. We fetch the opcode by reading the program counter. Right? Yeah, I think self, oh, this needs to be a mute self. So PC counter, the program counter is in PC counter, program counter. Let cur op, like a raw op. We'll do self.memory of self.registers.get reg PC. Oh, I need the PC registers. Registers, we can do .get PC. Pubfn PC. This doesn't need a mutable version of self. Get doesn't need a mutable version of self. It just needs self, array and self. Pubfn PC. This returns a U16. Self.pc. I don't want this to be pub. Yep. Emulator. Ooh. Wait a minute. The program counter can't be U8. Right? I don't think it can be P8. Yeah, it has to be a. Yeah, because then you can index it. What am I talking about? Yeah, of course. Of course. That'd be a P6 or what? P6, P8. What am I? A U8. A U8. Oof. I don't know why I would ever think this is that. Okay. Yeah. U8. U8 cannot be indexed by U8. You're lying. Isn't it? I guess it's technically a U size because it's the program kind of represents. But self that registers dot. We'll just like dot try into, and then we're gonna expect unable to cast U8 to convert to a U size dex. Self dot registers dot advanced PC. So we read it. Let parsed let opcode is raw opcode dot into. So this is where you get the nice. Program counters. Program counter is a U8. The opcode. Do we need to shift it by 2? Or is it the program counter might actually be 2 bytes? Because you read. Oh, I think so. You're like at the beginning of it. It is so it itself is a U8, but then you need to read 2 bytes. Like first half. We need to like form this into like first half. That second half is self dot memory index was 1, and let raw opcode is, which is a U8 U16. It's the first half. Oh, we can do U16 from BE bytes. First half, second half. The trait opcode from U16 is not satisfied. I thought we had this. Oh, we have a try in too. Yeah. We can do some error handling here. We really should. Yeah, let's add an error here. Error.rs. Emulator error should not be in here. It should be in error. This needs to be added into it. Mod error. Under an opcode, and then the emulator. All these can basically return results on like what happened if anything failed. So this is a results of an opcode or a error, emulator error. An opcode. Fix an error. Registers. We need a advanced PC. Move PC forward 2 bytes. Do check if there's anything left. To do probably a balance check or something. Self.pc plus equals OX. We need to jump 2 spots forward. Yeah. Okay. Nice. Type annotations are needed here. With the use size, bro. I wonder if this works. Let's just do self.cycle like the 4 times. Or blank in 0 to 4. Let's just like debug print this. Oh, what did I do? Oops. Let's just like debug print this a lot. Let's see what it is. 4 times. And then the main m.start. Self.cycle. We'll do 4 clock cycles. Let's print this opcode. All right. See what this is. Cargo run. Literal is out of range for U8. Ooh. Yeah, because we're not starting at OX200. We're what's OX200? We're starting like at address OX200. Wait. Why don't we just keep it as a addresses are 2 or yeah. All right, addresses are 2 bytes long. Wait. I had this wrong. This is a U16. But when you get it, you divide it by 8. This is a U16 because this is the address. Yes. And when you advance it, you go by OX2. That might be wrong. That is probably wrong. We'll do index divided by 8 and index. Yeah, I don't know if this is going to work, to be honest. Oh! What's this? Unknown opcode. 98? Why is it unknown? Let's do a println. It printed hello world not because it ran the ROM, by the way. That's like the default thing. Let's see what the halves are. 0 and 0, and then together it's that. Cool. So I'm definitely indexing wrong. Such a hard time visualizing the address space here. Because so we store a hex number. Where's my pen? Let's write some notes here. So we have a long list. X 200. The next memory address after that. The next 2 bytes. So O X 201. That's 1 byte. 202 be the next. So we push the I think, dude, bitwise outs are so annoying. Bits are hard, man. I haven't done bitwise stuff in forever. So you have 200, but that's not the 200th item in the array, right? Isn't it? Why can't I index as this as a... Wait. Yeah, it's like the 200. It's always 200. So it's not 200 decimal, it's 200 hex. So dividing by 8 makes no sense. This might make sense. There we go. Hell yeah. We read the first instruction. Dude. Question is, why did it only print once? Shouldn't I, aren't I looping 4 times? Yeah, I have a lot of errors, but it's okay. Wait, why is this not working? Wait, am I bugging? I bet that's cool though. We got the registers, dude. My brain is like fried right now. But it works. I want to get a little bit more progress on before I end the stream. Playing this loop. Here. Some good old debugging here. Wait, I'm in there once? Wait, that's what? What? Am I stupid? Wait, okay, that one works. Was 0.4 does not mean a range to 4? Why? What? Whatever. I'm stupid. So we have an unknown opcode after, which makes sense because we haven't done that. It's A500. Is that correct? Is that what we rewrote? We were looking for? A500. What does A500 do? A5 ANNN sets the I to the address NNN. Okay, I can do that. What's the I register? I don't think we should keep this as like a separate thing. I want to split this up. Yeah, I want to like this. Oh, but it's 12 bits wide. I actually can't do that. Yep, all good. There's beans rooted I. VI. Can't can't use size it. I don't know if I like this. We might refactor it. It's 12 bits wide. That's not fair. Doesn't because then the other ones would all be U16s. Which you know what? It could be, but when you then get I, why does I have to be? That's gross. Okay. We actually don't even process this though. Okay, wait, yeah, back up. I like went on. I was on the wrong thing here. My mind's jumping everywhere. We actually get the opcode, but then we don't actually execute it. FN execute exec opcode. Before we do that, oh my god, I'm jumping around right now. Keep up with me. Git add, you commit, check in, add, check in with, in start support for decoding. Nice. Here we go. More progress. Before we start to decode more ops, I want to get exec op though. I don't know if this could fail. Maybe it can. Who knows? For now, I don't. Let's just assume it doesn't. Maybe it can. All right. Whatever. We'll just assume it does. Actually, we'll just turn it okay for now. So we're gonna self and then an op, which is an opcode. We're gonna match in the opcode set vx register value fn exec set vx. I want to split these up. Otherwise, these branches are gonna become huge. Code. Yeah. This can't fail if it's already parsed it. Self.registers. Here we go. Set the register to the value. What is this, U8? U16? Oh, it's U8. Okay. I don't know if we actually need to set these as different functions. I think they're all going to be pretty self-explanatory. I'm going to keep it like this. Call me crazy. Never done this before, so I have no idea if this is actually a lot. Or I don't know if this is actually going to work. Like, I don't know how complicated the instructions get is what I'm trying to say. No op. That's not even a thing, is it? Emulator registers opcode. Don't need res. Fetch opcode. Self.exec opcode. Opcode. That was weird. Opcode. Can the cycle? Oh, because you could fail a parse. Oh, because the cycle could fail. Emulator. Occurs. Yeah, because we're calling functions on it. This can be unwrapped too. Self.cycle. If let this e to error. Nice debug print. Cool. Nice, dude. All right. I want to print at the end of this. I want to print the entire emulator. Which means that registers has to derive debug. I just want to look into it to see if it's actually setting these registers. Then in main, don't need this. I'm gonna println a nice debug print. Of the M? Do it after. No, what am I doing? How do I run? Okay, so we have a lot of memory. Wait, I didn't really think about that. There's a way to like debug print this, the memory. We actually ran this exact same issue with the PNG check in the other stream. It's okay for now. So we actually don't care about it before. Well, this might be useful. Well, we already know it printed the memory. Yeah. Okay. I just want to print the registers, honestly. Just let me in on the registers. I don't care about the memory. I think. I kind of do actually. Yeah, okay, it's fine. We'll just do pub on this for now. Okay, a better way to do this is to have a proper debug implementation. Yeah. Sure. I don't want to do it right now. I do not want to worry about that stuff right now. I don't want to worry about like figuring out um how to debug print that, how to remove how to show all the memory correctly. Man, I'm losing it here. It's getting late. Okay. I don't want to do it more than once. I just want to do it once here. Okay, there we go. Here's our ROM. Okay, we see the set VX instruction. When we're setting V2, so V0, V1, V2 to 120. But it's hex, so it's actually like, let's see, what's 78. It's the radix. What are you talking about? X is 120. Yeah, 78. Yeah. 0x68. So hex 78 is the same thing as decimal 120. Our PC is now at 514, which is true, which is correct because then the last time we ran this, it's saying it's running at A500, which it doesn't know. Nice. Is this where we added the EST opcode? Yeah. Git add start exec opcode. Nice. That is good. All right. I'm getting pretty tired. I think that's where I'm going to call it. But that was a crap ton of fun. I knew this project was gonna be fun, but that was like way more fun than I thought it was gonna be. To be honest, I'm having a great time. It's just one of those projects I think is so good with Rust because you can just abstract stuff nice. We have a nice enum reg, like our enum for our registers. We have these nice opcodes, and it's still fast. We can go all the way in at the byte level when we need. We can go all the way up at like these nice abstractions when we want. Great. But I think that's it for the stream. I'll probably post. I think I'm gonna post this on YouTube after. I'm probably gonna stream tomorrow. Just because I'm having a blast. I don't understand anything you did, but glad you had a fun stream. Listen, man, it takes a little bit to grasp. I think with Rust, but hopefully you got something out of it. I'm glad you stayed. I'll probably stream tomorrow. I think for a few hours, probably the same time. Like 7 to 9, I think might be my go-to spot. I think it's a good time slot for me. But if you don't already follow me on Twitter, follow me on Twitter. If you don't already, that's I'm on there all day, every day. So that's if you have any questions, reach out to me on Twitter. If you want to follow, see where this when to follow when my next stream is. If you want to follow that, stream announcements. You know the hell, I don't know. My brain is falling apart. When I'm gonna stream next, follow me there. Anything at all, follow me there. Shoot me a DM. I'm always around. Thanks everyone for coming. I'll see you in the next one. Peace.